Furniture resting on the floor. It usually see that the heavy furniture such as sofa, table, chair, etc. are kept on a floor for an extended period. Furniture will be in a stable position until any force acts on them. Even after applying the force, if the furniture returns to the same position, this furniture is considered to be in stable equilibrium and is a perfect stable equilibrium example. Birthday cap resting on the ground. A birthday cap that we use generally will be in the shape of a cone. The cone will rest on any surface through its circular base if we observe. At some point, if you try to tilt the birthday cap slightly, when released suddenly flips back to its exact position. So, we can consider the birthday cap to be in a stable equilibrium point, and it will be a primary stable equilibrium example. A bottle of juice resting on its base. A juice bottle that we use generally will rest on any surface through its base. If at some point, if you try to lift the bottle slightly and release, it shifts back to its exact position. So, we can consider the juice bottle to be in a stable equilibrium point, and it will be a primary stable equilibrium example. Another aspect that makes this bottle stay in its stable equilibrium is gravitational potential energy. As the juice bottle moves from its position, the central gravity increases because the point of central gravity shifts away from the equilibrium. So when it loses gravitational potential energy during any movement, it indeed comes back to its original position, maintaining stable equilibrium. Plate on a dining table. Similarly, when the plates are placed on a dining table at rest, no force acts on it initially. After some time, if you slide the plate by applying some force on it, and if the plate slides back to its exact position, then the plates are said to be in stable equilibrium and will be one of the real-life stable equilibrium examples. The vehicle stays at stable equilibrium on the street. A vehicle usually parked on any street will maintain its stable equilibrium unless an external factor acts on it. When you try to move the vehicle, at that time, it experiences inertia and shifts back to its exact position by again attaining the stable equilibrium. Then we can tell that a vehicle can be at stable equilibrium when parked on any street, and it is the best stable equilibrium example. Book on a study table. If you observe that the book is lying on the study table and try to lift it to some extent and drop it suddenly, then it will fall in the same place, it will land in the same place, and will be in a stable equilibrium. The coin on a paper. Coin stays on a paper for a long time, and even if it is flipped, it will come back to its stable position. It stays in an equilibrium position for some time, even after it gets disturbed, it will be in its stable equilibrium position. It is an excellent stable equilibrium example. An object suspended by a spring. When you suspend any small object with the spring, you will observe some up-down motion. After a while, the object attached to the spring will be at rest. This point is considered a stable equilibrium position, and after undergoing specific movements, the object will attain its stable equilibrium position, and it is a prominent stable equilibrium example. Bob of the pendulum. Bob of the pendulum, or any pendulum that we use during any physics experiment, can be a tremendous stable equilibrium example. When the bob is in its mean position, it will be in its stable equilibrium. After some application of force, it moves to its extreme ends and returns to its mean position again. In this case, we should observe that the bob moving away from its equilibrium point again comes back to the same point, attaining stable equilibrium. Ball suspended by a brick. While trying to suspend a small toy ball with the help of heavy brick and thread, you will see that after oscillating many times, the ball comes to rest at some point and stays still. Same as in the case of bob and pendulum, when you swing the ball after reaching its extreme ends, it returns to its mean position and attains stable equilibrium. The ball oscillates similarly to the pendulum and the bob. Marble in a bowl. When we place a marble in any bowl, it will oscillate itself and come back to the point where the gravitational potential energy will be less. This point will be considered as the stable equilibrium point where the marble will attain its stable equilibrium. When it reaches the mid-region of the bowl, then it will attain stable equilibrium. Clock and pendulum. Bob of the pendulum or any pendulum that we use during any physics experiment can be a tremendous stable equilibrium example. When the bob is in its mean position, it will be in its stable equilibrium. After some application of force, it moves to its extreme ends and returns to its mean position again. In this case, we should observe that the bob moving away from its equilibrium point again comes back to the same point, attaining stable equilibrium. Frequently asked questions on stable equilibrium FAQs. What is the simple meaning of stable equilibrium? The term stable means that the body or object does not change the state in which they are situated. If you try to move any material and come back to the same position, that material is said to be in stable equilibrium. It also gives the meaning that these bodies don't change their position. When can we say that the system is under stable equilibrium? We can say that the system is under equilibrium when it comes back to its equilibrium position even after the slight movement. When we disturb the body in equilibrium, it makes sure that it moves back to the same position. It is considered in the equilibrium. If it is fixed to that position without any disturbances, we can infer that the system is under stable equilibrium. What happens to the stable equilibrium of the body when a specific force acts on it? When a specific force acts on the body when it is in equilibrium, it tends to travel in the other direction of the movement. If the body is moved slightly from its equilibrium, at that time, the body experiences some force. If we measure the total force, it will be available in the opposite direction of the movement of that body. What are the essential conditions required by the object to be in its stable equilibrium? The essential conditions required by a body to maintain its stable equilibrium are: there are two conditions of stable equilibrium that should be satisfied simultaneously for the body. The first condition tells that all the external force that acts on the object when added must become equal to zero. The second condition says that both external torque and force acting on the object must become zero when added together. What method do you adopt to increase the stability of a body? The primary method we use to make the body in its stable equilibrium is by altering its central gravity and base width. First, you can try to reduce the body's central gravity or center of gravity to higher its stability. The second thing you can try is by increasing the width of the body or object's base. Mention the critical factors that affect the object's stability of equilibrium. The vital factors that undoubtedly affects the stability of any object that is in equilibrium are: more body mass makes the body maintain a stable equilibrium. An increase in inertia helps the body to be in stable equilibrium. If the center of mass is lesser, then the object will have a more stable equilibrium. If the size of the object's base is more and more prominent, then even the stability will be more. One more critical factor is that the central line of gravity must be appropriate to the object's base. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.